All right, everyone. Welcome to the first IGIS Introduction to Drone2Map presentation and demonstration. I will start this off with a short presentation that covers the principles that you'll need to know for using most photogrammetry software, but that includes Drone2Map being one of the suite of photogrammetry applications that are out there. I will have mention of Pix4D Mapper here and there just because they're very similar. And in fact, Drone2Map previously, as up to a couple of years ago, was using the Pix4D photogrammetry engine under the hood, but just with a different interface until ESRI, the parent company of Drone2Map, uh, ended up buying out or developed their own software and bought out whatever patents they had to do to have their own application in-house. Let me share my screen and we will get started here. All right. So if you have any questions, we'll save them for the end. I'll make sure that I leave enough time for that. And if you do have questions during the presentation, please feel free to throw them in the chat. My colleague Robert Johnson is on here and he can respond to some of those, or I'll return to him when I get a break later on. I'll probably get in the slipstream of talking about various aspects of Drone2Map and photogrammetry in general. But let me do one thing. I gotta change. Trying to find how to turn off. Just one second. Participants. There we go. I had to fix one little thing in my Zoom here. All right. But yeah, then I'll return to those as we get going. Just really quick though, before we get started, in the chat, if you could mention please put in the chat if you have any experience with any kind of photogrammetry application. That could include Pix4D, it could be ArcGIS Metashape, might be Drone2Map. Just include that in the chat. And also any other comment that you might want to add there, like you're interested in using this in the future if you're using drones in your program in any way. And just as a note, you might not even know what we're going to be covering, but I'm super excited about Drone2Map. It has developed a lot in recent years and the workflows are amazingly smooth. In fact, I think I'm going to finally transition from Pix4D to Drone2Map probably starting now. From what I've went through kicking the tires this week to see if all the kinks have been worked out of it that I was hoping had been worked out, and my major complaints with it seem to have disappeared. So this looking much better. Oh, so I see someone's using Drone Deploy, Pix4D Capture. Pix4D Capture is a different thing, by the way. That's an application for flying and collecting your data. The Pix4D Mapper is a different application that's similar to Drone2Map. As I mentioned before, it's Drone2Map used to run Pix4D underneath the hood. Drone Deploy is another application that's out there. It's a cloud processing option that's available. It's good, but it's more of a black box and it doesn't let you do your processing kind of in-house and well, once you have a license for nearly the low cost fee. Good. So I see some web ODM. I see a number of options that are out there. Good. So I'm going to get going into the slides, hide my floaty. There we go. There we go. I had to hide a couple of things. If you put stuff in the chat, I might not see it after right now because I'm tucking things away so I can see everything else on here. So but I'll return to the chat to answer questions later. So just a little bit about myself and my program. I'm part of the Informatics and GIS statewide program. If you're not familiar with this, my name is Sean Hogan and I'm located in Davis. I am the one person there for my team The rest of my team is spread out between UC Berkeley, the Kearney Research and Extension Center, Hopler, and Hopland Research and Extension Center. The IGIS statewide program is one of many, depending on how you count them. It could be anywhere from 12 to, if you count state institutes, even more than that. Our program is mostly inward facing, doing professional development, research, spatial technology, IT support. We wear a lot of hats within our team. And we service all of our UCANR affiliates and outside of that across the state. We have specialties in training, GIS services, research, drones, as we are touching on today. Another slide of our team. Director is Maggie Kelly, a program coordinator, Andy Lyons, myself, Shane Fire, our GIS guru, as I like to call him, Robert Johnson, programmer extraordinaire that's on with us today, Priyanka Vyas, and Genoa Stars. I mention everybody here is because we all have our specialties. We have a lot of overlap working with GIS and informatics, but each of us has kind of our niche where if, say, you need help for your program, we have office hours, and depending on what your needs are, if it's, say, drones or remote sensing, I will show up at the office hours. If it's our programming and a number of other things, Andy Lyons is our person. Shane Fire, Robert Johnson, programming, GIS, informatics, and then Priyanka and Genoa have their own specialties in GIS, rangeland ecology, social applications of GIS as well. If you go to and you might have already done this to find this workshop, but if you go to the IGIS, the UCANR-IGIS webpage, there's a workshop list. We have that rolling out on a periodic basis where we'll put up some for the fall, and then we'll put some up for the spring, and we'll do that throughout the year. In addition to that, you might want to refer to our YouTube channel. This recording will be added to the YouTube channel sometime next week. Typically takes me a couple of days to edit it and render it and upload it. And this will be along with a ton of other workshops that are recorded there, pertaining to everything from web mapping to story maps to field maps as a mobile data collection app builder, ArcGIS Pro, a number of different things, spatial analysis with R, lots of different learning avenues that you can go there. And I mentioned office hours. You can sign up for our office hours also on our website. You just look in the resources, and there's an option to sign up for Monday and Tuesday afternoons. And that's open to anybody, not just A&R people. And so we try to help out with and continue the effort that we do with our trainings and other research projects to help support our colleagues and our affiliates. Good. Now on to Drone2Map. So this is a reality suite, sometimes referred to a reality engine is one of the terminologies that ESRI or ArcGIS have used in recent years. And I was saying earlier, this is my new favorite photogrammetry application as of just this week now, having seen that it's been improved significantly in the last couple of years. But what is that? I'll talk about photogrammetry in a minute, but it's a desktop photogrammetry app that enables drone image processing immediately post-flight. You can run this in the field. Usually you would do that on the rapid options, I'll show you, or back in the office on something with a little bit more horsepower like a desktop computer. You can also, depending on the size of your project, that may or may not be necessary, but now it will chug through natural color RGB imagery, thermal imagery, as well as multispectral data sets, which has been very limited in not so recent past. So why Drone2Map? So this is a part of the ESRI ArcGIS ecosystem, or the constellation of their applications that are out there. And this is the one thing that's well, there's actually another thing I'll show you here. I was doing some comparisons with Pix4D, pretty much the dominant photogrammetry application that's out there right now. But one of the nice things about it being a part of the ecosystem of ArcGIS applications is that it integrates really nice. And you'll see what I'm talking about when I just push the one button that says open an ArcGIS Pro, and it opens there and you don't have to do anything else. It's the time savings of that alone is enormous if you've used any kind of other photogrammetry app. So it provides things like image centers. You'll see that in the automatically when it pops up. It has rapid and fast reduced resolution orthophoto production that you can do in the field to spot check, or if you all you need is something quick to process your data. Kind of like, but not quite as simple or is smooth for field work like Pix4D Fields, but very good. Creates true ortho, flat ortho mosaics with the color balancing, and then a bunch of different 2.5D data products like digital surface models, digital terrain models, and elevation contours. I say 2.5D because in reality, it's you don't have the ability to look underneath things like see like the bottoms of trees. It really is a draped type of elevation products, but still it's yeah, very useful. Couple things about the versions of Drone2Map. There's two. There's a standard version and there's an advanced version. Before I continue, just know that if you are part of the UC system, or especially UCANR affiliated, you can go to the UCANR-IGIS website where I mentioned you can find or find some of our training notes, some of our office hour options. Along with that, there's a request for software, and you could go in there and request Drone2Map. And we have a bunch of standard versions for our division. We don't have very many advanced versions that are available, but the good news is the standard version now has grown to be way more powerful than it was just months ago. Amazing. There's very little need for the advanced version. As we can see here, this is what you get with your standard version. You get the 2D points, the positions of your photos. You have templated processing options that are available. You get true ortho, full resolution ortho photos. So this is kind of this is a throwback. I might mention that a lot of this, or part of this slide deck, came from one of my late colleagues, Paul Bass, and he used to really harp on how funny it was that they call it a true ortho in Drone2Map. It's a little pedantic, but ortho means true in Latin, so it's like true. But that's I could appreciate that. It's just a funny way of them phrasing that. But regardless, what that's referring to is the true positioned or true relative position ortho that can be dropped in as a layer into your GIS software. The digital surface model is a product that's an elevation model that is essentially the top surface of the area that you're flying over and mapping, as opposed to the digital terrain model, which is a not directly calculated model. It subtracts objects above ground level using thresholding, like the steepness of, say, the side of a house or a tree, to create what's a theoretical ground level elevation model. Just as a side note, if you want, this works pretty well sometimes, not always, but it works pretty well. But you can subtract the digital terrain model from the digital surface model in your GIS to get a canopy height model using raster math. I digress. There's you can incorporate ground control points into this now, which is fantastic, as well as elevation contours as an option, and multispectral calibration into reflectance, which was very lacking at one point for the standard version. Now it's included there, and I'll show you how to do that shortly. So almost everything you need for GIS is included in the standard version. The only things that I've noted that are really, or that I've noticed that are not there, and this barely ever pertains to anything I do, is point clouds and textured mesh for three-dimensional visualization. And if you need to do more in-depth, like last like point cloud analysis, which sometimes comes up in some folks' research, but generally not in our typical GIS workflows. LAS file, by the way, is the same file format that was became popular from LiDAR, light detection and radar ranging systems. So the same kind of output in a point cloud, all coming from the photogrammetric processing. And finally, textured mesh. That's kind of like the photorealistic 3D draped models that you could kind of envision being in something like a 3D gaming software. So here's some more examples of products. If you're familiar with photogrammetry, you get your orthomosaic, you can get your NDVI or other indices that come out of that, point cloud with the advanced version. But key among these is your digital surface model and digital terrain model. Very useful in your GIS applications. And one of the things that makes drone data so powerful for analysis as opposed to aerial or satellite imagery is that you get that elevation dimension that you can add to the analysis. So just a little touch on photogrammetry if you're not familiar with it already. And I'm not expecting everyone's born with the knowledge of photogrammetry. That's not a common sort of thing that you come across. But it's essentially based on parallax, like your eyes used to judge distance. In this case, this is a simple representation. So using stereophotogrammetry of two planes. And through trigonometry and geometry, you can calculate the elevation of key points that are auto-identified by the software during this processing. So if you get the base of the tree and you get the angles, and then that you tie that to the telemetry data, which by the way is written to each image that a drone takes. The drone has a GPS on it and other instrumentation. Sometimes it includes angle and so forth, but usually it's the main things are your altitude, your latitude and longitude. Each time a drone takes a photo, that information is written to what's called an EXIF file, which is paired. You don't see it in your, say, your Windows file browser, but it's whenever you have like a list of RGB images, for example, each one of those hidden from your view has an EXIF file that has telemetry data written to it. And the software utilizes that to be able to position the outputs from the processing into something that is usable in a GIS. But using those different angles in complex calculations, especially when you're using more than two, and sometimes 50 or 100 different view angles all combined together, the software can then create, using a process or a term called structure for motion, can recreate the 3-dimensional or 2.5-dimensional shape of objects using multiple angles of parallax. This can include a massive number of tie points. So sometimes I like to kind of compare this to the way that phones for a while, or sometimes cameras, you could take a picture at one angle, another angle, another angle, another angle, and then say create mosaic, and it would stitch those together into one nice long mosaic. Well, it's like that, but on an incredible amount of steroids, with a lot of processing power to create full near 3D renditions of surfaces. This is just a screen capture from one of my projects from Pix4D. I can bring that up here shortly just to kind of as an example of how photogrammetry applications work. But in this case, this is a forest up in El Dorado County with a set of images, and 57 of those images could see the same X, Y, and Z, X and Y being the easting, northing, and Z being the altitude of the position. And with that, you can reconstruct the surfaces. This does require a lot of computing power, though, I might mention. Again, sometimes I've seen projects, by the way, that will have as many, I think the most I've seen is like 500 plus million key points to lock together images. And this is all based upon overlap. I don't know how familiar everybody is with drone operations and mission planning, but they typically work on overlap between images. And if you have just a little bit of overlap, you only have a few key points to tie to, or tie points sometimes are referred to. If you have more overlap, you get far more. Pix4D, there's not a lot of best practices reported uh, on ESRI sites that I could find. In fact, there's very little to the point tutorials on how to use Drone2Map for some strange reason. Usually you see a lot of video tutorials out there for applications, but so I refer to sometimes Pix4D's standards, which are basically going to be the same. And they note that you should have roughly around 1,000 match points per pair of images to really connect them together for a good orthomosaic and photogrammetric processing. So say for a 20 megapixel camera, this would include 75% overlap. Here's another way of looking at this. When you fly, typically you're flying something that looks like a lawnmower pattern. Someone came along and said that was a single grid pattern, as opposed to the one to the right, which is a double grid, which looks just like a grid to me, but a hatch pattern is what might be referred to. But the key thing is that each one of these images will have a frontal overlap, sometimes called a forward lap or a front lap, and then a side lap. Depending on the type of surface that you're trying to cover, you may need less or more overlap. We won't get into mission planning here, but just an example of that would be in forest, you might need 90%. If you're flying over a desert, maybe 70%, just because of the nature of the amount of relief on the terrain and the number of look angles that the drone's photos have on the surface to get enough of those key points that I was mentioning before, those tie points to lock the images together. Good. So another thing to know about is ground control points. If you need highly accurate results, and this usually is needed for two reasons. There's more, but the main two reasons are that you want to do change detection and you want your images, your image products to be completely aligned from one flight to the next, whether they're the same day or this next month or the next year. But you can use ground control points or GCPs to lock your processing outputs into have very accurately positioned results. That way, with change detection, you don't get false positives for change when it's really just a spatial error that's causing the change, not actual change on the ground. Another reason is if you need to tie your image products to some very specific ancillary data, spatial data that is. And an example of that might be a sprinkler emitter. And you need to know that if that green patch in your image is actually where the sprinkler's at or not. So that's you're tying it to some other type of data is why that's important sometimes. If neither of those two things are the case and you're just looking at relative positioning, like across your scene, just counting area, you might not need ground control points. I'm almost done here, by the way, the presentation, and then I'll jump into the little demo. And by the way, Drone2Map is really easy to use, so it's not, it's simple. You'll see shortly. Reflectance. This is one other thing that I love that Drone2Map does now is that you can use a drone, like in this case, this is a Mavic 3 Multispectral Pro, and using it over a ground control, or excuse me, a calibration panel, I can calculate for reflectance. That's important if you want to scientifically study your data. If it's just the values of the image or the sensitivity of the camera, like I say, a typical RGB camera only collects like RGB with like a digital number. And usually that's something like a number of values 0 to 255, for example, for an 8-bit image. That doesn't tell you too much about how truly reflective that surface is relative to something else. But if you use a calibration target and think of this as a more like scientifically rigorous white balancing, and you can barely see it, but on the drone there on the bottom, there's a little teeny dot on the top of it on the back near my hand. That's a downwelling sensor that clicks the illumination down. And then that recording that target can later allow you to calibrate your image products into reflectance. So then you can compare them from one day to another day when the illumination like qualities are different, for example. This is important because in terms of multispectral data, which is what one of the things I'll look at, is that we're used to thinking of RGB just in the visible spectrum between, let's say, about 450 and 750 get ballpark, 730 ballpark for blue, green, red parts of the spectrum. But multispectral cameras will also see the red edge and the near infrared part of the spectrum, typically, that are much, much more sensitive and much more reflective when it comes to healthy vegetation, as you can see in this chart off to the side. That green line being a spectral signature of a healthy plant, where you have this spike in reflectance of vegetation that's usually about 10 times more uh, 10 times brighter than the normal visible spectrum. And what that gives you is much more contrast to detect both health of plants and also differentiate between different types of plants. Something that you might like to refer to just in terms of practical things is computer power. This is something from Pix4D. Actually, I believe I may have actually had a hand in helping develop this once upon a time with one of the old developers at Pix4D, On God, that came to our first drone camp. By the way, if anybody's interested in more education around drones, IGIS, along with a bunch of our colleagues, hold a kind of a premier drone training event, short course in the Monterey area in June each year. But I digress. Again, back to this. You can refer to this. I'll make the slides available to you when I post it on the. I'll include it in the information about the video recording on YouTube. But but knowing what kind of processing power you need for different projects is really useful, because this turns into big data fast. Just in case anybody needs to know, here's a bunch of information about the pricing of Drone2Map. This was as of June of this year. That is, unless you're a part of the UCANR affiliated system, where you, again, can go to our website and request a standard license for your use. We have plenty of them currently. And then getting to know Drone2Map. I'm going to include on here, here's some resources that are available to you, step to step for getting your own license administration set up, and how to install Drone2Map and so forth, which I won't go over right now for time's sake, as well as a couple other references, part of which is what I'm including here in a much more condensed format. Good. That is all for presentation. I know that was a fire hose. Let me check the chat, make sure there's nothing. Okay, someone asked about how well does Drone2Map work for mapping areas with high vertical and high angular surfaces, like road cuts, rock outcrops. So can you add vertical overlap to the image sets? No, okay, yes and no. It will only render a 2.5 dimensional surface at surface level, but if this comes to mission planning, you can angle your photos so you're flying with your drone with, like, say, instead of looking straight down at nadir, you can set it to like a 65% angle and then fly in that double grid pattern or the hatch pattern, so you get a lot of different view angles on the sides of objects for much, much more robust elevation modeling in your products. Good. So now I am going to, still sharing, I'm going to reduce this down. I'm going to show you, let's see, how many of these things do I have open here? Just 2 for now. I'm going to show you what a typical product might be for an RGB image. This is from Drone Camp with an RGB product output. I can come back to this in a moment by showing you how we get to this point, but this is the output that you might see from a typical product. If you look out here in the background, you see what would look like Google Earth almost, but this is a higher quality. But if you get into the drone imagery, you can see very high detail results in the imagery. Again, I'll show you how to get to this point in a moment. And you also get 3D outputs. Again, 2.5D, and sometimes this takes a second for it to come up because it is pretty processing intense to render this, and it takes a moment for it to come in. Good. And it's slowly but surely coming in. Good. So this is what the output will look like. You can see this type of model here that is available only in the advanced options, which I'm going to just highlight that right now, and then we can skip past it because it really won't matter that often. Only in the advanced options do you get this kind of product output. And that's because in the standard version, if you look over onto the right-hand side of my screen where there's manage, which will be the default thing that pops up once you load your data, by clicking the 3D products in DSM, mesh, 3D mesh, and the point cloud, that's what renders this in your outputs. Standard versions don't do this. I just brought that up because that's really the only difference is you don't get this cool visualization. I believe I brought this up. Here's another, actually, I'll come back to that shortly. It's from a different site. Good. So I'm going to show you how to create this product. And by the way, let me see if I have that up in ArcGIS Pro yet. No, I don't. This is one of the lovely things about this software application too that you can do is you can just export this into ArcGIS Pro really easy. If I were to click on this open in ArcGIS Pro, you end up getting, it just opens just like this. And now instead of being in Drone2Map, I'm in ArcGIS Pro, and I still have the 3D map that was produced. Oops, no, I don't, because I did this in standard version. That's right. But regardless, you get the output. Now here's something pretty neat, and I'm going to show you what, if you are a Pix4D mapper user, I just was, for my own curiosity's sake, and one of the reasons why I loaded this up like this, I wanted to see what the difference was. So this was what we're looking at right here is the true ortho that was produced in Drone2Map. The output of Pix4D for the same data set, which I processed again this morning, looks like raster layer, swipe. If I zoom in, this is Drone2Map, this is Pix4D. Let me zoom in more because maybe on Zoom it doesn't appear so much. You can see it's very similar, but Pix4D is more pixelated. That's because in the processing of Pix4D, it has a higher level of resampling to, I think, about 5 pixels, as opposed to just individual pixels as a default in Drone2Map, and processing in about the same amount of time. Also, it seems like the color balancing is slightly better too. Again, if I go over, you can see it's pixelated and it's higher contrast with a little less shading. So if you're wondering, and the reason why I bring this up, if you're interested in switching from Pix4D to Drone2Map, this might influence you on that. It certainly has made me think that, at least for RGB imagery, it is a heck of a lot. It gives good products. But let's put it that way. I haven't tested on enough sets to know that it's consistently better and rigorous scientifically, but it's good. Now let's show you how to get something like this real quick. And most of you won't be using ground control targets. So I want to show you just the basic workflow of Drone2Map for basic imagery. And this is so easy, it's kind of crazy actually how easy it is. I'm going to start a new Drone2Map project here. It takes a second for it to come up. Starting it fresh, this is what it'll look like for you when it comes up, or something very close to it. And I am only going to use RGB imagery this time. So I'm going to just use, say, D2M. I'm just going to give it just a generic name. And because I don't want to pollute or the folders where I've created stuff already, I'm going to put this in a trash folder, which, by the way, I highly recommend if you do any kind of drone work or GIS work for that matter. I have a trash folder that I empty out periodically because I create a whole bunch of different files that I don't really want to hold on to, say, well, after today, because I've done it a bunch of times. This is just for demo right now. So I'm creating a project and putting in a trash folder there. And now I want to add images. And there's a couple of ways that you could go about that. You can add images using the add button, add images from just the images themselves, or you can add a folder, or you can do my favorite way of doing it is I will go to, let's see, I'm going to go to my drone projects to use the same set of images that I did for the last one, so it gets the same result. I'm going to go to my drone projects, CSUMB, and data. And here's the flight data that I had that created the project that you just saw a moment ago. As I click on the first one and Control A to grab all of them, and then I just drag and drop that into the window here. That's my preferred way of doing it. Just so you know, if there's something wrong with any of these, you'll typically get a little warning that goes across the top. It's like orangish in my case, but you should see all of these are check green to show that there's no problems with your images that came in. Couple options that you have across the top, which by the way, you can change later are your rapid processing. I mentioned that you might use in the field, the 2D products option, 3D products, which you can also adjust. And then there's batch and custom, which are a couple options that usually don't come up, so we won't cover those right now. But now, since I have these in here, I'm just going to leave it on the default of the 2D products, and I'm going to click create, noting after I put in the project name, where I wanted it, and the location, and the images, and then create. It'll take a second for it to come up. This, by the way, will be the workflow that most of you will probably do, assuming that you're not using ground control targets, which requires a very high precision GPS unit like a Trimble Geo7X or something to that effect. Bad Elf with uh, with vicarious calibration, or rather the using ground station data to correct it, differential correction that is. But in the most time, you'll bring in your RGB image just like this. You'll see where your positions are. You want to make sure that it's actually where you expect it to be and that there's no major blot like missing sections, which by the way is not uncommon when you use a micro SD card or an SD card that doesn't have a fast enough read write speed. The drone will get confused and it'll just stop taking pictures for a while, and it might start again or it might not. But you want to make sure you have all your images here. And once that's in there, there's a bunch of other options across the top that you will see, and I'll come back to those in a little bit more robust way of processing for multispectral data. But most of you would just go in and click. First you would check across the right-hand side under Manage. You'd probably include Digital Terrain Model. That used to not be available, as I understand it, in the standard version, but now it is. So you get out of this your orthomosaic, your digital surface model, digital terrain model, basically consisting of all the things that you need in most GIS applications, making sure you have those all checked. You will not have these available to you in a standard version, but you will in an advanced version. And then once those are checked, you would just click start. And then you'd process and you would end up with something like this, only without these green check marks that you might see in there that are ground control targets, because we didn't include those in there, which I will do in the next short demonstration of how to add those.
Is it,
Once
are,
that's Yes,
Are GCPs added in a separate step then?
yes, they are, and they always are in every photogrammetry application that I've used.
Yeah, yeah, like Pix 4D is like 3 steps if you
Yep.
use it. Yeah.
You do it at the beginning in you actually that's one nice thing in a way about Drone2Map is that you can do that before you don't have to do like process through step one and then do it. In Drone2Map, you can actually do it right at the beginning. Sometimes it's a little easier if you process all the way through and then you do it, but you can do it right at the beginning in Drone2Map. And that's what I'm going to do right now is I'll show you the steps for that and for radiometric calibration.
So sometimes I do GCPs and then do another step for control points.
Yep, we're going to do that right now.
Okay.
That's exactly what we're doing. So I'm going to bring up another Drone2Map project. I'm adding quite a few of them in there. While it's coming up, I'm going to go find the data that I want to use so I can just drag it and drop it in there in my Drone2Map demo. Here's data. Good. So this time I'm going to do another. This is now, so you can see as while I was taught, like kind of doing a number of things there. All I did is I brought up another Drone2Map project. I'm going to start it with a new project name and location, and I'm going to add in a different set of data so you can get the full suite of the things that you can do. And the nice thing about this will take more than, for most of you, more than 5 to 10 minutes is what I'm going to do this in like 5 minutes, but I'll be able to cover all the bases to show you how easily it can be done. I'm not going to go through every step, but I'll show you what the steps entail. Well, excuse me, I will go through each of the steps, but I'm not going to redundantly do them over and over and over again for every radiometric calibration target and every ground control point. So here we go. So in this one, I'm going to just name this one G2M MS for multi-spec demo, a workshop. I'm going to browse and put this in my trash folder again, like I did the other one, because there we go. And you saw I was bringing up the imagery already. All I'm going to do is click on the first one, click Control A to grab them all and drop them in there. By the way, this is a really nice thing. I really like the Mavic multispectral drone. The thing is up until June, at least the last time I tried it, they were not supported in that image format, and specifically the way the EXIF files were written. Apparently, that's what I heard. Is Drone2Map wouldn't accept the Mavic multispectral data. Now it does. I checked it earlier, and it works just fine, which is fantastic news to me. One of the reasons I'll transition to it. But if you load that multispectral data in here and it's mixed with, say, your RGB imagery or anything else, you'll see a warning, and then you'll have a bunch of orange checked off areas where those are non-supported images for the type of processing. But this time I put all in, this is Mica Sense Altum data, not including the thermal band that I just plugged in there. And I will click create this time. Still on the 2D products. And then it'll come up. This is at our Lynn Cove Research and Extension Center down near Visalia, south of Fresno. And a short area field, it's a navel orange field that we just did a little sample data set for training purposes that we collected. So anyhow, so you can see we have all these positions. Actually, each one of these images has 5 images that are associated with it because there's blue, green, red edge, and near infrared data for each one of these photo points. And so the way that we treat these different, usually what you do right at the beginning is you check what you want over on the 2D product side. And this time we're going to add in ground control targets. before we even go to the like in Pix4D where you have to process first and then do it, you can do it right from the beginning here. And the way I would do that, it was I click Control, Import Controls, and then I'm going to go to, I should have moved this file folder. Come on, there we go. Now it rolls. It was frozen there for a second. I'm going to go to my drone camp data. This is using data from a Pix4D exercise, by the way, because I wanted to be able to compare them. I'm going to go to the GCPs, and these GCPs are collected specifically for this site. And I'll click OK. Just a little note you'll see here where if it'll come in, it'll automatically detect the coordinate system that the GCPs are. And it'll down here, it'll say latitude, longitude. Don't worry about that. It automatically recognizes that Y is the northing, X is the easy, not latitude or longitude, and then elevation is correct. So I just click OK. And then across the right-hand side, you'll get this control manager that'll pop up. So there's to add positions to this. What I'll do is I'll click on the first option, the show image link editor. And it'll take a second for it to come up. And why it's taking that long, I don't know. I can hear my fan running on my computer. Good, there we go. So typically what you'd want to do is you would want to add, I'm going to move this over just a little bit because on the screen here, you can see which of these is highlighted. So if I go over to the top of this link image editor and switch to number 2, it'll switch to 2 down below, or number 3, it'll be the bottom right-hand corner. I'll just go with number 1 for right now. You would add in at least 3, but usually around 5. At least I'd say about 5 control points per image position for something like this. This one's really easy. It's set, by the way, if you can see in the top corner of the image links, it says distance. That's how it's adjusted. So the distance from the in theory, the distance from the position, sometimes there's errors there that will screw that up. But the list of these is the distance from the ground control point. If I click on the first one, this is what we see. And right below it is the ground control target. And I just click on that. Now note that there's a 1, 2, 3, 4, and 5. All of the 135 photos are taken from the same position. So we'll want to move on to another one. So instead of 135, we'll want to go at least to 134 on a different image and then zoom in and click on that one. If you click all from the same 135 image, you're not going to have you won't be getting real photogrammetry because all of the image angles are going to be from the same position because the Altum takes all those photos at the same time in one position and then moves to the next. So 134, 152, this one's got a bad angle. That's because the drone was tipping while it turned. And so now I have to go back to the next one. And so I would do this over and over again for number 1, then 2, then 3, and I'd get all of them done, and then I'd just click OK. Once I'd done that, then I would do my radiometric calibration. You can see that I could do that without having to do the pre-processing, like I mentioned before. Just a little note, though, if you're not sure, if I bring up that image control target again, sometimes in complex scenes, it's hard to tell what images are like your targets are at. Like say you're really you're having like there's a lot of ground control points that are close together. You might go in on this and click on the image to see 141. That one's almost above it. And then I would scroll down to 141 here to find it. This is taking slightly longer than I thought. I thought I could do it in 5 minutes. It's looking up 7. Luckily, radiometric calibration is really easy. And the way you do that is you go up to your flight data across the top. You click on flight data. You'll go up to radiometric calibration is the option, second option over that pops out. And now I'm going to switch this first one from quality type of radiance to reflectance. And then we'll just repeat this for each one of the bands. If I click the little button box there, and then it'll allow me to click the folder and then go into the folder, which the first one, blue, is the underscore one image. I just know this. Underscore one's blue, underscore two's green, underscore three's is red, and so forth. I come in here, get blue. I'll click this little box, sketch area for calibration, and then click twice, and then click the third time. So it creates a little polygon, just a 3-click thing. And then add in your reflectance. I just happen to know this one's a 0.59 reflectance. You can get that, by the way, by looking up the QR code on your panel and then click OK. And then I would do the same thing using the next box for green and red and near infrared. And when I'm done with each one of these, I would say OK. And just like I did before, I would go back to home, and I've done my ground control targets. I've done my radiometric calibration. I would just click start. And when that was done, it would look like something like this. This would be the result that would come up after that starting process. You can see that it has it all in here nicely, but this is a neat thing, which is a huge time saver, and I'll be done after this, is if I open this in ArcGIS Pro, and I click yes, then it already composites all those bands together, which is a hassle using other applications like Agisoft and Drone2Map. When this comes in and it opens up, you will see that if I go down to the true ortho and you see there's the red is red, green is green, it already auto detects which band is which. I don't have to do any rearranging. But if I right click that, I can see I have the ability to change it to a false color infrared if I want to, just like this. So I just changed the band order around to create that false color infrared that some of us remote sensing nerds like to see when we're looking at vegetation. And with that, I think I covered every step that is needed for using Drone2Map. And that's even in the more complex case of ground control targets in radiometric calibration. And so I will take questions in a minute, but for the rest of you, thank you for coming. And I will send a evaluation form out to you shortly after this meeting, this presentation. And if you could fill that out, I would greatly appreciate it. I'll throw that in the chat now, and I'll take questions. But for the rest of you, thank you and have a great weekend.